So part A is basically asking us to do, right, velocity at time in general. So that's basically talking about the velocity functions, that is taking the first derivatives of the position function. So when I take derivatives, I will have to use the quotient rule. So derivative of the numerator, 1 times the denominator, 1 plus t squared, minus the numerator times the derivative of the denominator, 0 plus 2t, and all over, and denominator square, 1 plus t squared, quantity squared. And simplifying a little bit, the reason why I want you to simplify is this is the type of problems that we're going to be seeing later on that you need to simplify, because notice that right here in G, I'm asking for the acceleration function, which is I need to take another derivatives out of it. So when I simplify this, right, distributing 1 and then distributing negative t, that will give me 1 minus t squared, and all over 1 plus t squared, quantity square. So now, to answer part B of this session, this question, which is asking you to find out the velocity at time equal to 3. Right? The velocity at time equal to 3. So substituting that, time into the velocity function that we just found, 1 minus 3 squared, all over 1 plus 3 squared, quantity squared. So, which will give me negative 2 over 25. Okay, after you simplify it. And this is basically feet per second. Okay? And part C basically asks you to find out when is the particle at rest. So asking for what time the particle is not moving. So right here, what we need to understand is this part, when it say particle is at rest, that basically means my velocity is 0. So, so basically what we are asking us to find out is when v of t equal to 0, and what is my t is going to be. So that's the question, particle at rest. So now what I'm going to do is I'm going to try to find that function value. Okay? So v of t, that is basically 1 minus t squared all over 1 plus t squared, quantity squared, that is equal to 0. So when I multiply both sides by denominator, that gives me this, and which is I got t equal to plus or minus 1. And we know that the time is not, don't have negative time, so therefore my answer will be particle is at rest when t is equal to 1. Okay? 1 is after 1 second. Now, the next questions, part D, is asking us, when is the particle moving forward? So what does that basically mean, moving forward? Like, how do we know moving forward? Okay? So this portion right here. So moving forward, that's basically talking about going into a positive directions. And that's happens, right, when the particle is moving forward, when the value of the velocity, right, the value of the velocity function is a positive. So I should say that the function value of the velocity function is positive. Right? Anytime that giving me that, that means like the particle is moving forward. So therefore, moving forward, that means I will need to find out the velocity function is greater than 0. And at what time would that give it to me? So when the velocity function is greater than 0, that's basically say that 1 minus t squared all over 1 plus t squared quantity squared that is greater than 0. We are solving for rational inequalities right here. And we know the denominator can never be 0, and then we already found out what is going to be 0 of this function. So we know that 0 of this function is t equal to -1 or t equal to +1. And we already know that this negative is not applicable in this problem. So what do? We basically, like we did in algebra, try to find out the solutions of this inequality, which tell us I'm going to have a real number line, and here's 0, and here's 1. And what are we looking for is the value of v of t, right? The function value of the velocity function. So in the interval 1 and interval 2, right? And we need to find out what it's going to give us. So now checking it with the number 0.5 right here in interval number 1, I got the velocity functions is a positive value, because when you plug it into right here 0.5, so this top part will be positive value, then the bottom part will be positive value. So therefore, in this interval, I will get positive value. And when I plug it in 2 on interval number 2, right? And when I plug it in the same thing into velocity function, and the top part will give me a negative value, and the bottom part will be positive. So therefore, it will be a negative value. So now we found out that the particle, the function value of this velocity function is positive between 0 and 1. In terms of interpretations, that basically tell me that the particle is moving forwards within this time interval. So now to complete this questions, now I can say that therefore, right, particle is moving forward on when the time is between 0 to 1. So if they ask you, when the particle is moving backward, that's basically talking about what? When the value of the velocity function, right, is negative values. So in this case, anything between 1 through a positive infinity, the time is moving backward. But that's not what the question asks us. So continuing this, what is the next part of this question? Right? So part E is asking you to draw a diagram to illustrate this particle, right? So part E is basically asking you to draw the diagram of it. So if I'm drawing the diagram, and this is basically how is that going to look like in two-dimensional one. So here's my initial point when my t is equal to 0, and then this particle is going to be moving forwards, and then it stopped and then turned around. When it stopped, that means it changed the direction of it, okay? And then go back. So when is that stop? And we know that the particle at rest when time is equal to 1 from the problem number part C, and then it keep on going. So therefore, now I see that my particle is going to be, moving forwards between 0 and 1, and then moving backward 1 to infinity the time. So this is the diagram that we see. Any questions so far? All clear, right? So make sure you understand that, what is a moving forward means in terms of derivatives and then mathematical points of view, and then continue. So now the next one is asking you to find the total distance traveled during the first 8 seconds. So for this problem, right, total distance on the first 8 seconds. Part F. So when we talk about the total distance on the first 8 seconds, this is usually what we tend to do it wrong. We might be doing like, s of 8 minus s of 0, and that talk about like, oh, the first 8 seconds, the distance between 8 seconds and 0 seconds, that will give me the total distance. No, that's not true. Okay, so because of the particle is moving forward and moving backward, when you talk about the first 8 seconds like this, s of 8 minus s of 0, that's basically talking about the displacement, not the distance. So you got to be careful with that. Okay, so in order to talk about this first 8 seconds, we already saw the picture already, such that the time is t equal to 0. That's initial, and then it moves backwards and then go like this. So right here is the time equal to 1, and then let's say 8 seconds right here, t equal to 8. So I need to break it down into 2 situations. First, I need to find out the distance from time 0 to 1. And then I need to find the distance from time 1 to 1 second to 8 seconds. And then adding up those 2 times together, that will give me the total distance. Follow so far? So from this on, now I can basically look at it as first part, right? Is the distance from the time 0 to 1 second. Right? So that's the first case. So this is basically s of 0, absolute value of s0 minus s of 1. And when you plug it into the position functions, so I'm not going to write it down detailed, okay? You can do that in your calculator. You can give me like this on the test also. You don't really need to tell me like exact. So that will give me, if you plug it into the calculator with the functions, that will give me 1/2. Okay? So remember, we are evaluating in the S functions, the position function. Now, if I continue the same thing, right? Part 2 of this, we need to find out the distance when the t belongs to 1 to 8 seconds. And this will basically mean that s of 1 minus s of 8, right? Absolute value of that, because we want to make sure that the distance are positive distance. So this will give me 49 over 130 if you plug it into the formula. So now, finally, I can talk about the total distance, which is the main thing that we want. Between, the time between 0 second to 8 seconds. So that's the first 8 seconds. So that's basically, we are adding 1/2 plus 49 over 130. And this will basically give me my final answer, which is 57 over 65 if you use a calculator. And since these are in feet, so make sure you indicate your units. These are feet. Right? Any questions on this part F? Finding out the total distance. Okay. If not, then let's move on to the next questions. So, yes.
Can you go just up again, just so I could take a picture of the notes on the top? Yeah. Thank you.
So the next question is basically telling you to find the accelerations at the time t, and also the value of the accelerations, right? What is the acceleration after 3 seconds? So that's what the question is asking. So to find out the acceleration functions, I need to take the derivatives of the velocity function. So to do this next column, G. So the acceleration functions, that is basically taking derivative of the velocity function. So when I take the derivative of this velocity functions, this gave us, okay? And remember the velocity function is right here. Let me pull it up. Right? I'm not going to go all the way up, like this part right here is a velocity function. Right? So when I take derivative of that, that will become derivative of the numerator, which is 0 minus t squared. And then times with denominator, so 1 plus t squared quantity squared, minus, and numerator, 1 minus t squared, times with derivative of denominator, which I need to use the chain rule, which is time 1 plus t squared, and then to the first power. And using the chain rule, which is taking derivative of inside, that will be 0 plus 2t. And all over 1 plus t squared. And when you square it again, this will become t to the fourth power, right? That's what we're going to get. So now what we need to do is we need to simplify this part, right? So that I can continue talking about something else. So when I simplify this, and what you need to be able to see is this part right here, so that you will not be writing down a lot of steps. And on the first term, I have 1 plus t squared. On the second term, I also have 1 plus t squared. So I can factor out 1 plus t squared and reduce with one of the denominator part. That will give me 1 plus t squared. Originally, it's supposed to be fourth power, but because of we reducing with 1, it will become third power. And then continue simplifying on the numerator, right? And this will help us to get oh, I made a mistake right here. Do you guys see that? When I take the derivatives, I only take derivative of 1. I forgot to take derivative of this part. So this should have been 2t right there. Okay. So when I distributed that, this will become negative 2t minus 2t to the third power. Let me do it a different way. Distributing is like, too much work. So what I'm going to do is I'm going to try to write it out so that we can continue a little bit faster. So not distributing, but just write it down. That will be negative 2t, 1 plus t squared, minus, and this will become 2 times 2 is 4t over 1 minus t squared. Okay. So now what I'm going to do now is I'm going to factor out negative 2t and then combine the rest, and this will give me negative 2t. And on the first term, I only left with this. On the second term, that will become positive 2. And then when I distribute positive 2, and then combining it up, that will become 3 minus t squared. All over 1 plus t squared to the third power. So I skip a lot of step right there on the algebra part. Okay? So making sure that you're all okay with this. So now I have my velocity acceleration functions ready. So the question
Professor?
Yes.
Can you explain that last step really quickly?
This last step.
The minus 2t.
The recording has stopped.
So the last step is basically this. You factor out negative 2t. So what's going to happen is inside it will left with, on the first term, it will left with 1 plus t squared plus 2 times 1 minus t squared. And when you continue on this part, that will give me 1 plus t squared plus 2 minus 2t squared. And 1 plus 2 is 3. T squared minus 2t squared is minus t squared. So that's how I got it. Okay?
Okay, thank you.
So those are like, the algebra part that, you can do on the side work, or you can write it down over and over again. Okay? So these are really up to you. Show me like, a couple of steps and then skipping is enough. But on the test for your own good, like, write it down so that you will not make any mistake. Okay? So,
This meeting is being recorded.
now, when I look for the second part of this questions, we want to find out the accelerations at 3 seconds. So basically, I want to substitute into this functions right here, which is negative 2 times 3, and then 3 minus 3 squared, and then 1 plus 3 squared to the third power. So when you evaluate this using your calculator, right, that should give you 9 over 250. And since this is acceleration, this would be feet per second squared. Any questions before I move any further from here? All right. So what is the next question that they're asking for? Right? So the next question is asking when the particle is speeding up and when the particle is slowing down. This H and I, we're going to do it together. And why? Because what does it mean by particle is speeding up? Okay, the particle is speeding up when the value of velocity functions and the acceleration function are the same sign, meaning the velocity of a velocity function, right? The value of velocity function and the value of acceleration function, they both have positive or they both have what? Negative. That is what I mean by the particle is speeding up. If the particle is slowing down, that basically means that the value of the function value of velocity and accelerations have the opposite sign. So for the velocity functions, we already know that when it's going to be positive value and when it's going to be negative value in part D. So we need to find out for the acceleration part so that we can compare. Okay? So to find out the acceleration functions, right? For the acceleration function part, so I'm gonna do H and I together. So the first thing that I need to know is I need to know when the acceleration function is equal to 0. So that's basically given to me negative 2t times with 3 minus t squared all over 1 plus t to the second power all the way to the third is equal to 0. So when you clear the denominator, that will be negative 2t times with 3 minus t squared, that is equal to 0. So which give us t is equal to 0, and then 3 minus t squared equal to 0. So this tells us that my t is equal to 0, and then t is equal to plus or minus square root of 3. So this allows us, right, to do like before. Here's my real number line, and again, the time can be 0 or the time can be positive, cannot be negative. So we discard this negative radical 3. And this time, what we are interested in is we are interested in looking at the value of the acceleration function. So like before, I'm going to pick a number, okay, in each interval. But before that, let's try to find out what is the square root of radical 3 so that I can pick the number easily. So the square root of radical 3, that is basically approximately 1.7 something. Okay? So when I pick the number, I'm going to pick 1 for the first interval. And when I substitute into the acceleration function, okay, when I substitute into acceleration function right here, and the top part will be the first factor is negative, and the second factor is positive, and the denominator is positive. So negative divided by positive, that will be negative value. And then the next part, I'm going to choose, 3. And the reason why is because I already evaluate a's of 3 already, which I know that is a positive value, so that could quickly can be done. Following so far? Now, with this, and recalling what we did before, okay, on velocity functions, 1.7 approximately. So remember that in the velocity functions, let me do this right here. Recall the velocity functions. We have 0 and then 1 right here, and our value on the velocity function is a positive right here and then negative the rest. So this is the value of velocity function that we saw before. So now, from looking at this two, integral graph, okay, then I can start answering my questions for my h. So when is the particle is speeding up? So I can say that particle is speeding up on the time interval of, and notice that from 1 to rod 3, both of them has a negative value, right? Both of them has a negative value. So that basically tells me from 1 to radical 3 seconds. That's particle is speeding up. And for the I part, the particle is slowing down. When the time is, when the velocity functions and the acceleration function has different signs. So that means from 0 to 1, the signs are different. And from radical 3 to positive infinity, the signs are different. So the particle is slowing down from 0 to 1, union with radical 3 to positive infinity. And that basically concludes this problem.
The recording has stopped.
Any questions on this? Are we all okay with this? Now you make me hungry now. What are you eating?
Broccoli and rice. Sorry, I didn't have time.
No, it's okay. I just happened to turn on the little site picture things, but it's okay.
Should I turn my video off?
So are we all okay with this so far? That's the main thing.
Let's go back.
We good, right? So what you need to remember is, in this case, is the meaning of it. Okay, the meaning of each term. Like when the particle is at rest, what does that mean? For the test purpose, you need to know that when the particle is at rest, that's the velocity is what equal to 0, right? So what happens is usually when the velocity is equal to 0, that might tell you you might be changing direction. And then what is moving forward means when the velocity is the value of the velocity is positive. In that time interval, the function the particle is moving forward. That's what we mean. Okay? And as well as speeding up and then slowing down. Are we good? All right. So let me move on to the next example. Right? So the next example is basically this.